Hello, everyone. Welcome to my talk on generative AI for good, from concept to practice. My name is Dr. Yuhao Chen. I'm a research assistant professor at Systems Design Engineering in University of Waterloo. I lead multiple projects in generative AI related to medical imaging, nutrition estimation, as well as avatar generation. So why would we use generative AI? How would we use it? Generative AI, like models based on the generative adversarial network, or models like OpenAI GPT series, has a wide range of applications. Here are some reasons why we use generative AI. First, content creation, including images and art, text, music, data augmentation, simulation and modeling, gaming and virtual reality, personalized content, blah, blah, blah. Now, this is all generated by a generative AI. Did you get my point? We can use generative AI to increase our productivity and then to generate content for our presentation. So here's something that I personally use generative AI for, which boosts my creativity when I introduce generative AI to other people. Here's one example that I use, which is I want generative AI to tell a joke with visual aids, of course. So I asked ChatGPT, can you write a dad joke on a cat that can be turned into a comic? One frame. Here's what ChatGPT gave me. Certainly, joke. Why was the cat sitting on the computer? To keep an eye on the mouse. And then ChatGPT gave me a scene description to describe the scene in one frame. So here's what I use to input into a generative AI specifically for images. This is a typical Stable Diffusion generative AI web page that you can get from the internet by searching Stable Diffusion web AI. And then you can input the phrase that you got from the ChatGPT to this web AI, and then hit that generate button, and it will generate an image for you. Well, this is what I got. A cat sitting on a table by the computer. This has most of the things that I input into the prompt. The prompt is a desk with a computer, the mouse next to it, and a cat lounging comfortably atop of the keyboard, eye fixed intently on the computer mouse. Well, the cat in this frame doesn't really look at the mouse. Maybe let's try again to hit that generate button. This is another image I got. Well, it kind of satisfies all the requirements in the prompt, but it's not a very good image. Let's try again. This is an interesting image. If we can make the cat a little bit clear, it will be a fantastic joke. Oh, this is a much better image, but maybe we want to have the cat focus more on the mouse. Yes, this is what we need. This perfectly demonstrates the joke. Why was the cat sitting on the computer? Because it needs to keep an eye on the mouse. Now, besides using generative AI to increase your creativity, we can also use generative AI to boost our productivity. So in this case, I create an avatar to do the presentation for me so I can take the day off at home.
Hello, I am Yuhao's avatar. I am here today to replace Yuhao to do his presentation.
Do you like my avatar? Here's what I used. I used my voice together with ChatGPT created script and input into a voice clone software, which generates my speech with cloned voice. Then I use my speech with cloned voice with my headshot and input into a software called SetTalker, which generates a talking head for me. The nice thing about this is that I can generate a talking head on demand with any script I want. For example, this was the avatar I generated previously for this presentation, but it was not very time-consuming to do it again. Despite all the hypes, using generative AI still brings several concerns. For example, in this case, an artist used generative AI to generate an image and won an art contest. But artists are not so happy about it. There's also copyright concerns. In this case, Getty Images sues AI art generator Stable Diffusion in the US for copyright infringement. Generative AI can also be misused. In this case, someone used cloned voice of a little girl to scam her mother. Another issue with generative AI is that it can be biased. For example, an MIT student asked AI to make her headshot more professional, but it gave her lighter skin and blue eyes. The student probably don't want to use this as her headshot because it's nothing like her. So how can we help? We identified the following 3 ways. First, we can use AI to detect data issues such as copyright infringement. Second, we can promote the positive side of generative AI by using it in good ways. Third, we can develop methods that have better controls for the content generation to ensure the generated data is not biased. With all of those in mind, we introduce our Generative AI for Good initiative. In the following, I'm listing several efforts we made towards Generative AI for Good initiative. First, to tackle the copyright issue, we proposed Deepfake Art Challenge benchmark dataset for generative AI art forgery and data poisoning detection. So in this case, we used multiple data augmentation and imprinting techniques to generate fake data in order to trick generative AI to generate fake arts. And with this dataset, we were able to develop better methods to detect generative AI art forgery. The second effort we made towards Generative AI for Good initiative is that we used generative AI to generate medical images to enhance our dataset in order to overcome the data imbalance issue. In the example on the right, we show that our methods generate prostate images that can have fixed prostate shape while providing various textures around it. By generating images with fixed prostate shape, will give us more control over the data. The third effort made towards Generative AI for Good initiative is that we propose a dataset for nutrition intake estimation based on a single RGB camera. In this case, we use Generative AI to boost our dataset size in order to improve models' performance on nutrition estimation for food images. As a part of this workshop, I would like to share a personal story about generative AI on strawberry picking. Every year, I go strawberry picking with my wife. These are some photos from last year. What I want to show you here is that if you look at the field, the strawberry field, you can see that you don't really get to see the strawberries in the strawberry field image. In order to see the strawberries, you have to sit down or kneel down to take a closer look at the bottom of the plants. And this is my friend, Ken. He went strawberry picking with us. So this picture perfectly demonstrates what a strawberry picking looks like. By the way, those are some delicious strawberries. I highly recommend you to pick strawberries in Ontario. This year, I went strawberry picking with my wife again. However, it rained that day and we forgot to take pictures. After we went home, I told my wife, why do we need photos when we have generative AI? So I went ahead and opened up this generative AI software. You can find this online by Google searching Stable Diffusion Web UI. So I opened this software and input strawberry field and hit that generate button. Here's what I got, a field full of strawberries and some greens. But it looks like a salad, right? Maybe I hit that button again. Here's something I got, a field full of red stuff. And again, in this image, at least there's some humans. But this image, nothing looked like the photos I took last year. So maybe it's not about strawberry field. Let's try again with a human in the prompt. Here's what I input into the Stable Diffusion Web UI. Woman picking strawberries in the rain. I hit that generate button again. Here's what I got. If you take a look at the left image, this is generated by a general purpose Stable Diffusion version 1.5. It doesn't generate humans with good body structures. So instead, I changed the model to a more portrait-focused model and generated two images on the right. As you can see in this case, human-generated have better body structures. However, now the strawberry grows on the tree, and there's something weird about the umbrellas. So I wonder what causes these problems. I further digged into what is used to train the Stable Diffusion 1.5 model. It was trained on Lion 5 billion dataset. One question comes to my mind. Does the dataset have the exact images we want? So by opening this website, I was able to search images in this dataset. Here are the results that returned after my search. First, I searched woman picking strawberry in the rain, which returns 0 results. Then I searched woman picking strawberry. Again, it returns 0 results. And finally, I searched strawberry picking, which gave me 53 results. Here are some sample images from the 53 results. Out of those 4, you can see there's only one satisfies my requirement. By scanning through the 53 results, I found this pattern. Photos that matches my requirement often have some picking strawberries, child picking strawberries, or girl picking strawberries. So instead of prompting woman picking strawberries into Stable Diffusion, I now prompt some picking strawberries into Stable Diffusion. Here's what I got on the right. It's much better, right? So this example perfectly demonstrates my first suggestion for back practice using generative AI is that you need to know your dataset well. Then our next question is, what do we do after knowing the dataset? Some of you probably have experienced this. The model is not generating what you want. So how can we fix that? We first want to find the cause of this behavior. In our nutrition estimation project, we first train a Stable Diffusion model on Nutrition 5K open source dataset. And this is what we see. The generated images are nothing like the input images. So in this case, the generated images do not look like what's inside the training dataset. And they look fake. This can be due to the case where the dataset is not diverse enough. Just like our strawberry case, we don't have enough samples on women picking strawberries. So the next question comes to our mind. What if we have perfect dataset? This time, instead of using open source dataset, we used our synthetic dataset to train a Stable Diffusion model on it. And the generated images looks exactly like the images in the training dataset. That is exactly what we want. This leads us to our next best practice, clean your data. So in this case, we clean our data with prompt engineering. In these slides, we show an example on hamburgers. We searched the Lion 5 billion database on realistic hamburger, and we saw that those images are not realistic. So instead of using realistic burger as our prompt, we instead use hamburger aesthetic score of 9 to collect a new data set to train our stable diffusion model. Here are the results. You can see on the top row, if we don't use this cleaning technique, the model generates images, sometimes that are not usable for nutrition estimation. And in the bottom row, with this cleaning technique, we are able to generate realistic burger images. We look through the dataset to train Stable Diffusion 1.5 on burgers. Specifically, we look at the captions, and we found this hamburger aesthetic score of 9 is very useful to shift through the dataset to collect images we want. This technique is only applied to Lion 5 billion dataset used by Stable Diffusion 1.5. This is how they sort their data, and then we can leverage this practice to shift through the data to collect data we want. It's still a long way to go. When we train a Stable Diffusion on various open-sourced food dataset, we experienced a lot of issues still. In the top row, when we prompt udon noodles, we can see there's a lot of issues, including watermarks, weird chopstick shapes, and noodles floating in the air. In the bottom row, when we prompt soup dumplings, you can see that the soup dumpling always comes with a soup, but in reality, soup dumpling is not in a soup. And there's also weird bowl shape in the generated images. In summary, generative AI is great for boosting your creativity, your productivity, and for more information, you can ask ChatGPT. But there's still many issues in generative AI, including copyright issues, biased generated results, as well as being misused in various ways. To tackle these issues, we propose Generative AI for Good initiative. Through this initiative, we can use generative AI to detect copyright issues, develop methods with controllable and consistent generation, as well as promote good use of generative AI in various applications. Finally, I used 2 examples to show some best practices when using generative AI. The first one is to really know your dataset and what's inside your data. The second practice is to clean your data. You can use prompt engineering or other methods to filter your data. To learn more about generative AI for good, please visit us online.